Welcome to part 9 of Zombies and Reinforcement Learning. So today we're going to be finishing up the conversion of this environment for OpenAI Gym. That's going to include some observation methods, as well as some changes to the step method so that we can start to get observations back from the environment for our AI to learn on. I'm going to go ahead and preface this and say that I am getting used to a brand new keyboard with a different layout. So my typing is going to be a little bit slow today. If you need to speed up this video, I completely understand. All right, let's start out with our first goal, just so you can kind of understand it from that side. So when we start our game, one of the first things we should need to do is call game.reset, something like that. And game.reset should reset the score to 0. It should, reset lives to 5. It should basically go back to the beginning of the game. It should also return an initial observation and info. So we should be able to get something like that from game.reset. Further, every time we call game.step, we should be able to get a series of items returned. So step should return observation. It should return reward, done, truncated, and info every single time. So when you call reset, you should get observation info. When you call step, you should get all of these things. So let's go ahead and start working on some of those methods. So inside of game.py, we are going to need we'll start with an underscore get info. So these are methods that are defined by the OpenAI standard. We're going to do get info, self. Okay. And then we're not actually going to use this info set, but we're still going to go ahead and code it out. We're going to say gun type num equals 1 if single in self.gun type else 2. Okay. And what getInfo is supposed to do is it's supposed to return a numerical representation of information about the environment that's not available in the main image observation. So this is if you want to return, additional things that you want the agent to know. We're going to train it without any of this, but if you use a different type of agent or you want to build a different architecture, this could be useful to you. So, and again, the whole point is that we're defining a full, a full environment here. So we're going to return health is going to be equal to self.player.health. Okay. We will define shotgun ammo as self.shotgun ammo. We will define gun type. And I defined that gun type num up there because I felt like a number was an easier. We'll go ahead and return self.gun type as as a text value, but I also wanted to have gun type num, just because if you were using this, as a model input, it's going to understand a number a lot more easily. You won't have to convert it ahead of time. Okay, and then we're also going to return the length of self.bullets. And again, we didn't use this, but you could conceivably need to tell the AI how many bullets are already out on the screen. One of the early things I was playing around with was capping the number of bullets instead of the bullet rate. So basically saying, hey, you can only have 20 bullets. That's not how we ended up doing it, obviously. We did a rate limit. But if I'd stuck with that, this would be very useful. All right, and then we need a similar def underscore get obs for get observation. That will also take self. And this is where we're going to actually pull down a copy of the screen from Pygame. So we're going to say screen array equals Pygame dot surf array dot pixels 3D, and we're going to pass in self.screen. Okay. We are going to transpose this to the appropriate height width channels. So screen array equals np.transpose. Oh, and you know what? We need NumPy. So I'm just going to come up here to the top, and we're going to import NumPy as np. Okay. All right. All right, so now we have NumPy. We can do NumPy.transpose. And we're going to pass in screen array. And then we're going to pass in parentheses 1, 0, and 2. All right, now what else do we need to do? We don't actually want to hand the AI a full colored, full-sized image. We want to hand it something much simpler for it to learn on. So what we're going to do here is we are going to downscale the image. So we're going to resize it. We're not going to resize it as small as we might something like Pong, because it is a little bit of a more complex game. If you bring it down to 64 by 64, there's not really enough information to play it. So we're going to do 128 by 128. A good way to tell if you've scaled something down too far for an AI environment is to actually print the image out and to see if it's something that a human could play the game on. Maybe not play the game on comfortably, but like looking at it, you see that there is enough information for you to play, even if it's, tiny and on a small screen. So I found that number was 128 by 128. So we're going to do downscaled image equals CV2. Oh, and we need CV2. So let's go back to the top. And we're going to import CV. Let me see what that import is. Nope, it is just CV2. Okay, let's go back down to our observation, our getObs. So we're going to say CV2 dot resize. And we're going to pass in screen array. And the size, which is 128 by 128. And we are going to go ahead and pass in interpolation. Equals, and this will be cb2.inter_nearest. And I'll be honest, if I remembered what this did, I would tell you, but I do not. Okay, downscaled image. Now we want to go ahead and cast it to grayscale because we don't actually need all those pixel values. We just need a basic grayscale image for the AI to learn on. So I'm going to call this grayscale equals cb2.cbt color. And we're going to say downscaled image and cb2.color. RGB to gray. All right. And then finally, we can go ahead and turn that into an observation that we can return. So observation is going to be equal to torch. We also need torch. All right, I probably should have looked at some of my imports before we got started. So we're going to import torch. Let's see. Okay. Okay. All right, so here we are going to say return, observation equals torch dot from numpy, and this will be grayscale dot float dot unsqueeze. And we're going to unsqueeze on dimension 0 there. And then finally, we can just go ahead and return observation. Okay, so our getObs method is done. All right, so the next thing we need to do is we are actually going to modify the step method a little bit. So let's start by just going ahead and doing our returns down here. So if we're in step, and we're only going to return 3 things, and I'll explain why in a moment. So we're going to return reward, which hasn't been defined. We're going to return self.done and truncated. All right, and we need to do some defining of some of these things. So we want rewards in a few places, and this is one of those things that's you know, you can kind of play with a little bit. I'm not going to pretend that the way I've got it set up is the best possible way for an AI to learn. It just happens to be how I set it up. So at the beginning here, we're going to go ahead and start out all 3 of these values. So we're going to say reward truncated equals 0 and false. Let's see. Initial observation. I'm looking at my own code and wondering why I put the false there. Oh, because I'm not being smart here. We're setting truncated to false and reward to 0. That was a dull moment. All right. So we need to think about what values we might want to include a reward. So the first thing is probably if we hit a zombie, right? So let's go ahead and say self.player score. So somewhere in here, score. There we go. That's what I'm looking for. So right under here, we're going to go ahead and say that if the player score goes up by 1, we're going to say the reward is plus equals 1. The other places, and you could, you know, if you were working with a more complex agent, which we're not going to be, you could say that it should figure out that things like hearts are bad, and maybe it should figure out on its own that hitting a zombie's bad. We're not going to do that. We're just going to go ahead and tell it right here. So if self.player health goes down, we're going to go ahead and say reward minus equals 1. So if you get hit by a zombie, you get a negative reward from the environment. If you hit a zombie, you get a positive reward from the environment. All right, and then let's go ahead and find treasure chest. We also want to go ahead and say if it was able to open the treasure chest. So if not treasure chest is open, we're going to go ahead and say reward plus equals 1. So we want it to, you know, get a little positive bump if it finds ammo. And then we also want to do the same thing under health drop. So we're going to say reward plus equals 1. Okay, so that covers our rewards. Let's see if we had a done option in here already. All right, we have not defined self.done. So we're going to come up here to the top and go ahead and say, let's go ahead and define our reset method, because this is going to influence quite a bit of this. So let's go up to the top. Well, not quite the top. Let's go up to the top of zombie shooter here. And we're going to go ahead and define a reset method that a lot of these things will go into. So down under init, and we're going to call reset from init. So we're going to go ahead and in here, let's see, how much of this do we just want to move down? Not all of it. We'll get there. Okay. So def reset. Okay. And that will take self, like everything else. And in reset, we're going to say self.done equals false. We're going to say self.level equals 1. Because remember, this is supposed to take it all back to square one. That's the goal here. We're going to say self.level goal is equal to 5. Self.max zombie count is equal to 5. Self.walls is equal to walls 1. Self.player, nope, not play walking sound, player is equal to player world height equals world height, self.world height. World width equals self.world width. And walls equals self.walls. Okay. We'll do self.player.health equals 5. We will do self.max zombie count. We'll also go back to 5. Self.zombie top speed will be equal to 1. Self.total frames will be equal to 0, because again, we're resetting. Self.last bullet frame will be a 0. Self.shotgun ammo will be a 0. Self.out of ammo message displayed will be false. Self.gun type equals single. Okay. And then we're going to go ahead and set self.bullets to nothing. And self.zombies will also be equal to blank list. And then finally, we're going to use those other methods we just set up, and we're going to return self._getops and self._get_info. Nope, not getops, get info. All right, there we go. All right, so that part looks good. So let's go ahead and go up back into our zombie shooter here. So we don't need a few of these things now. We no longer need self.out of message displayed. Out of ammo message displayed, we're going to get rid of that. We're going to get rid of bullets, zombie top speed, level 1, last bullet frame, total frames. I think we still need self.human and the sound configuration. That's fine. But now we can go ahead and say self. We'll need a couple of, actually no, we don't even need to capture the return values. We don't need them here. So we can go ahead and say self.reset. That way we're not duplicating code. All right, we're making progress. Now, the next thing we need to do is we're going to go back, well, hang on. I think we need to do one more thing with that done flag. Let me find it. Okay, this is what we need to do. So under the start next level, right above, instead of saying pygame.quit and sys.exit, we are actually going to comment those out. let's see, because we don't need them anymore. And we're actually just going to say self.done equals true, because we don't actually want to quit Pygame. We just want to, hey, return a done so that the AI knows that it can start the next match. All right, so at this point, everything in our get info here, or everything in our step function, should be getting a value. All of these things, it should be getting a reward, it should be getting done, it should be getting truncated. So the next thing we want to do is we actually don't want the AI to have to play every single step. So this step method is going to return once per frame. And that's a lot. Like that's going to return with very, very little movement each time. It doesn't actually require, we don't need the AI to have an input for every frame of movement. We want it to play, a little bit more like a human would. And some of that is a lot of it is just efficiency. If you're passing in 4 times as many frames, but it's not actually, there's nothing new in each one, then you're just filling up your buffer and using memory for something that's not actually training the agent to do anything. So what we're going to do, we are going to actually rename our internal step method to _step to show that it's internal. And we're going to define a new step method that's in charge of that looping function. Okay, so this is going to take step, action, and then it's going to take a variable called repeat, which we will default to 4. Okay, and you know what? I'm doing something weird here. I don't actually want to edit this one. I'm editing the wrong step function. All right, leave your original step function alone. We're going to come up here and do repeat equals 4. Okay, and then inside this step function, we're going to track total reward, and that will start at 0. And we're going to say for I in range repeat. So basically, do most of the same thing every time. So we only want to repeat. So let's think about what we're doing. So we're going to go ahead and call it the first time. So we're going to say reward done truncated equals self._step with action. Okay. So after that, we're going to append, because we're looping 4 times. So we're going to append total reward, or reward to total reward. Now we actually want, if the action is a fire, if it's anything except for movement. So, things like 5, 6, which I think we mapped to, let's see, we were going to map 5 to switch gun. We set that statically to false, but we'll go ahead and, cover it here. And then 6 is fire. So we actually want to set action to 0 at this point. We've already, so let's say you hit fire. You don't want it to fire 4 times across the next 4 frames. You want it to fire once and then, let that bullet travel for 4 frames. So that's what we're going to do. We're going to go ahead and say if action is equal to 5, or action is equal to 6, then action will be equal to 0, which is no movement. And then we're going to say if done, go ahead and break. Okay. And then this is also why we did not need to return an observation earlier. So at the end, we're going to go ahead and say return self.getObs. Total reward. Done. Truncated. Self.getInfo. Okay. All right, and then this should actually be somewhat testable. So let's go ahead up here. I'm going to say human equals true and sound equals false. I don't want any sound, but I do want it to run at a, sort of human scale here, human speed. And then I'm going to say we're going to print out, let's just start by printing observation. I want to make sure that we're getting the value that we think we're getting. Okay. Let's start there. Oh, no module named CB2. All right, let's go ahead in here, and we are going to go ahead and do CB2, and then also I think we left out NumPy. And then down here, I'm just going to do pip install -r requirements. Let me see what the actual name of that is. It's not CB2 apparently. OpenCV-Python is what that's called. Okay. Now we're successfully installing CV2, hopefully, and apparently updating Torch. Okay, it's still thinking about it there. So we're going to write a little bit of extra. Oh, there it did. It went. All right. Let's go ahead and run it and see if we succeed. Okay, so we're still able to navigate around the environment. You're going to find that this feels a tiny bit clunkier with the step repeat in, but it's not awful. It's just a little more clunk than it was with the original game, and that's okay. Again, this is the version that we're making it easier for the AI to play. Let's go ahead and we're gonna Control-C out of there. Let's go ahead and print out the rest of our variables. So we're going to go ahead and do let's do this. If reward, this is going to be temporary code just for testing. So if reward is not equal to 0, we're going to go ahead and print, let's see, reward, and we're going to make that reward. I don't want it to just be streaming information, but I do want it to confirm that we're getting the values that we think we are. So we're going to say done equals done. And I don't really care about info. And then what we're going to do is we're going to go ahead and write an image to disk here. So let's create a directory. We're going to call it temp, temp. And then we're going to say image array is equal to torch. We probably need to import torch up here. Okay. Also helps if I spell it right. So we're going to say torch dot clip. And then we're going to say observation, and this is just turning it into something that we can actually print to disk here, or dot squeeze. On 0. Okay. And then we're going to do 0, 255. Dot numpy. And we're going to say as type np dot, yep, let's come up here and import numpy as np. That's going to be required. And again, spelling. Spelling is important. Okay, so now we have NP. So we're going to do this as uint8. And then finally, we're going to say result. This is just to capture whether it was successful or not. We may not need this. CV2, which we also need up here. Import CV2. Dot I am right. And we're going to say temp slash screen dot jpg. Okay, and then we're going to feed in the image array. And there are lots of things that can get messed up here. If the channels get messed up, your image could be rotated in a weird direction. You know, you could have things in the wrong spots. Like, this is a really good check to run just to make sure that everything is working up to this point. Okay, so we're cruising around. We haven't had a score, so we don't expect it to print anything. Okay, so that gave us a reward equals 1, which is interesting. Hang on, let's try that again. Okay, no, reward equals 1. So you notice down here that it's not consistently printing when we hit a zombie, and it should be printing every single time there's a reward. See, it printed on that one. Okay, let's go see what's wrong. Something is broken. So, this is the problem. So right here it says total reward equals reward. So it's only printing if reward is the last one in the count. So let's go ahead and fix that. So that should be a plus equals. All right, let's try it again. And also let's go check our temp screen. Okay, that looks pretty good. We'll do it again in a minute and just make sure that it's, you know, in the right direction. All right, so now, all right, cool. We get reward equals 1. We got a heart collected, and that did reward equals 1. Let's let a zombie get us, and that gave us reward equals -1. And let's go look at screen. Okay, and this does look right. So we've got our wall down here. We've got our zombies, you know, where we expect them to be. You know, that looks like we expect it to. And you can kind of see what I mean about, you know, is the observation the right size for a human to be able to do something with it? And this kind of is. Like, it's not, clearly we're not getting the full features of our zombies. We're not getting the full features of our player. But you can tell which way the player's pointed. You can see the, you know, the shotgun direction. You can see where the zombies are. We should be able to see bullets if we, you know, were to go and shoot some bullets. This is enough information for a human to be able to, you know, figure out what's going on. It's not going to be enough information for the text to appear. You'll notice the text up here gets pretty mangled. So it's not going to be able to figure out how many lives it has, or that kind of information. It's just going to be able to see, you know, where zombies are and all that fun stuff. So if you needed the AI to have some of that other information, which we won't for what we're doing, but you could, that is where the info stack is going, or the info return is going to come into play. So I think we can go ahead and say this is working. We've got our rewards back. We've got our image observations back. This is actually in a spot where we could go and start to train our AI on it. So I'm going to say that's a great place to go ahead and stop the video. In the next video, we are going to go ahead and start coding out our AI agent, you know, our buffer, the rest of the program, to be able to train an AI to play this game. So I will see you next time.